Well, let's think about inferential statistics then. We spoke of the descriptive statistics, and that was the mean score of 26 versus 22 for the sample from printed pages versus the sample from the computer screen. Let's think about an inference. It consists of the techniques that allow us to study samples like these 30 people, 15 and 15, and then make generalizations about the populations from which they were selected. And from this output here, this data that's in your chapter, the researcher would have to make a decision. And the decision would be whether or not we can come to one of two conclusions. I know that sounded awkward, but let me fast forward a little bit here. One of the two conclusions could be, and I'm going down to step 3 here, the sample data show a 4-point difference, 26 versus 22, between the two methods of studying. However, there are two ways to interpret the results. One is that there's actually no difference between the two studying methods, and the sample difference is purely due to chance. In other words, due to sampling error between the two samples. Let's cover what that is. Here's a demonstration of sampling error. Two samples are selected from the same population, and you'll notice that the statistics are different from one sample to another, and that all the sample statistics are different from the corresponding population. So here's my population of 1,000 college students at a small college, say in Georgetown, Kentucky. The average age would be 21.3 years, an average IQ of 112.5, and it's 65% female, which is typical of a lot of colleges. I think that's roughly the percentage of our psych majors. If I took just a sample of 5 students, this sample has sampling error, which merely means there's a discrepancy between the sample and the population. Error often connotes slovenliness or human frailty. That's not the case here. In this case, we're talking about just differences, discrepancies that can't be avoided, particularly with small samples when we're getting something out of a population. So the sample statistics, the average age of 19.8, average IQ is lower, and only 60% female. On the second sample, you can see it's a different average age. 20.4 is still lower than the population. The average IQ is a little bit higher than the population. In this case, it's 4 out of 40% female, or 2 out of 5. So it can't be perfect. And sometimes we get sample errors that just don't look like the population. We were speaking of polling before. Here are the actual numbers of unavoidable sampling error, I should say, as it pertained to the 2004 election. It was George W. Bush, the incumbent, versus John Kerry, the challenger. And over on the right was the actual result on Tuesday, November 2nd, 2004. And I remember it because I lived in Colorado back then, and we happened to have this brutal snowstorm that came up out of nowhere on Election Day. But you could see that Bush won. Boy, that's a bigger margin than I remember. It looked like 2.4 points. I didn't remember it being that big. But he won by over 2.4 percentage points. And then here's a poll just a few days later. And I guess this would have been, Saturday the 31st? Am I right? Or Sunday the 31st of 2004. And you can see here the difference is 2.8. So did Zogby err? Well, strictly speaking, yes, in their 1,000 phone calls. But that's unavoidable. It's understood that there's going to be some skewing there, some unavoidable factors, if you will, that cause the sample to be different than the population. But again, one thing that makes these polls desirable is they often get the gist, and almost every poll in 2004 correctly predicted Bush over Kerry, as is the case with most elections. So in this case, I would refer back to number 1. There's no difference between these two studying methods, and the differences between this 26 and the 22 have to do with just discrepancies from samples and drawing from populations. It had nothing to do whether the material was on a printed page or on a computer screen. It's just pure sampling error. The second result is the one that the researcher would prefer, and that suggests there really is a difference between the two methods, and that the sample data accurately reflects this difference. For some reason, when people read from the printed page, they smell the paper. They like the feel of the paper underneath their fingertips. They like to close the book and open the book, and then maybe they make highlights in the book that a Kindle won't allow. Who knows? 50 things. There's something granular about reading a textbook that just is not afforded with a Kindle or an iPad or some equivalent device. So in that case, there really is. That's one interpretation, and that's the one that the researcher would prefer. Now, our decision will be numerical later on whether we'll enjoy statistical significance. And even if we do, however, we still have to basically entertain the suspicion, if you will, that number one is true, that there's no difference between the two methods and it's due to just chance.